Hi everyone, today we're going to be looking at Unit 2, Lesson 3 on binary. So the question is asked, what is binary? Binary is referred to as machine language. It's also referred to as the language of the computer. It's also referred to as zeros and ones, okay? So all the information that you process on the computer, all your images, all your sounds, every Word document that you have, the computer stores this in a series of zeros and one. In your exam, they'll ask you to convert from denary to binary. Denary is a number system that we use, sometimes referred to as decimal, and binary is the language of the computer that is just zeros and ones. So this question is asking you to convert the number 101 into its binary representation. To do this, we normally place it on a chart. And this chart, if you can look at the series of numbers, you can see that the numbers are raised by 2. So it's 2. 2 times 2 is 4, 4 5 times 2 is 8, 8 times 2 is 16, 16 times 2 is 36, 32. So you can see that the numbers are increasing when multiplied by 2. Okay, so we're converting 101. Let's go. So to do this, you're going to look at the series of numbers and you're going to look for the number that is the highest value that's under 101. So we can't use 128 because it's too high. It's greater than 101, so we're going to put a 0. We can use 64 because 64 is the greatest number under 101. Let's write 64 here. And can we use 32? Let's try to add 32 to 64 to see what we get. Yes, we can use 32. Can we use 16? If we add 16 to this number, I think it will be more than that. So we can't use 16. So we're going to put a 0 here. Can we use 8? If we put 8 here, will it be greater than 101? Yes, it will. So let's not use that. Can we use 4? Let's try 4. This will give us 100. So yes, we can. And we can't use 2 because this will give us 102. So we're going to put a 0 here, but we can use 1 here. Lovely. So if you add these values together, you should get 101. So the binary sequence for 101 is this lovely value here. Lovely. All right, let's move on. So if you look here in the series of number, this one is asking you to convert from binary back to denary. So all you have to do is to put this number on the same table that we discussed earlier, and you're only adding the numbers with a 1 underneath it. We're not adding the ones with the zeros, okay? 0 has no value, okay? All right, so when we look at it, when we place the numbers on the chart, we can see that we will be adding 128. We will be adding 32. We'll be adding 16. We'll be adding 4. And we'll be adding 2. And we'll be adding 1. When we put those numbers together, literally, if we should write them out. Oops, that's my alarm to go to work. If we should write them out on the and add them together like this, we will get 183. That's all it's asking you. This is the easiest way to do it. There's another way to do it. I can show this in a different video, but this is the easiest way to do it. So let's do an example together. I'm going to do another one for you. One for the binary, one for the denary to binary, one for the binary to denary, and then I'll leave this. You can pause the screen and then you can try the rest on your own. So this number that we're looking at is 69. What's the highest value under 69? We know we can't use this because that's too big. So let's use 64. What other number can I add to 69? Add to 64 to get 69. I can add 4. This will make it 68. And I can add 1. This will make it 69. I won't use these, so I will represent them using a 0. So my answer is 0, 1, 0, 0, 0, 1, 0, 1 base 2. Now, you are going to try these ones. Okay? Let me move on to this one. What I'm going to be doing, I'm placing this number on my chart. But it's always important for you to remember when you're placing binary numbers on charts, because you don't know how many digits they are. Always start from this side, from the right side. So I'm putting my 0 here. 1, 0, 1, 0, 1, 1, 1. Okay. Please note, I'm saying this because it's very important. Always place the numbers on the chart starting from the right side. All right. So what numbers am I adding together? I'm adding 128. I'm adding 64. Let's do that. 2 carry 1. That's 9. Carry 1. And then I'm adding 32. That makes it 4. 2 carry 1. That's 1. Oops, that's 2. That's 220. 224. And then I'm adding 8. I'm not adding 16 because 16 doesn't have that value. I have the 1 underneath it. So this is 2 carry 1. I have to do it like this, guys, because I want to make sure that you all understand what we're doing. I don't mind if you say, okay, we have to show the addition. I want you to follow along with me, okay? And then we have 2 here. And then this is 4, 3, 2. And then we're not adding the 1 because the 1 has 0. So the decimal equivalent value for this is 234. Lovely. So now that you have an example, I want you to try the rest of them on your own, okay, before you move on, because the answers will be shown on the screen. Still skipping. Here are your answers. Lovely. And this one says the computer record an audio file for someone playing a guitar, and it says convert the binary number to its denary form. You can try this and then we'll see the answer displayed here. Oops. Okay. And then this says hexadecimal. Let's talk about hexadecimal. Hexadecimal is base 16, and it's used to simplify how binary is represented. So instead of saying 10, 11, 12, 13, 14, 15, what they have done is replace the 10 with A, B with 11, C with 12 with C, 13 with D, E, and so forth. Okay, so let's try to map this out for you. Let's map this out. All right, so first of all, you need to find the binary equivalent. So what's the highest number on the 166? We have the highest number on the 166 is 128. So we're adding 128. 64, should we add 64? No, that will be too high. So we're not adding that value. Okay, are we adding 32? Let's see. 32. So we're saying this is 2 and 8 is 0 carry 1, and then this is 6, and then this is 1. So yes, we are adding 32. And then we're asking, we want to find values that are equal to 6. So we know that that's 4 and that's 2, right? And then we add 0 and 0 and 0 here as placeholders. Pause the video, slow it down if you need to slow it down, and watch it again if you need to watch it again, okay? So what we're doing now, we're going to split this binary number into groups of 4. We call 4 bits nibble, okay? So if you hear the term nibble, it's referring to 4 bits. But what we're doing to make this accurate, we are starting with the 4 on the right side. So we're looking at 0, 1, 0, 1, this part here. So we're going to separate it into its nibble value, which is this. If you notice, it's the same numbers I'm writing starting from the right side. And then if you look on this side, we're going to do the same thing starting from this side. So it's 0, and then we have 1, and then we have 0, and then we have 1. Good. So now that we have the 2 nibbles, what we're going to do is to show the binary representation. the hexadecimal representation of these values. So this, if we add 4 and 2 together, we'll get 6. So right here, we're just going to write 6 here. Good. Okay. Apologies. This side, we're going to add the numbers with 1. So we have 8 and 2. That will make 10. But we're not just going to write 10, okay? Because we need to check on the hexadecimal chart to see what 10 is used to represent from the denary value. So we have 10 as a denary value, and 10 is represented by A, and the 6 is a regular 6. So this is that. So your hexadecimal value is A6. Lovely. Yay. Let's move on. Let's try the last one, and then that's it, because I have to go to work. Okay. So, all right. So, you know what? You try this one. How would you do this? The number is 234. What values do you need to add together to get 234? What do you think? Pause the video, try it, and then I'll show you the answer. All right, I'm going to show you the answer now. Here's 2. You can try on your own. Yep. And remember, for numbers that is above 9, any two value number, we don't use the 2 value number. We use the letter representation. So the letter representation for 15, if you can check on the chart here, 15 is F. Okay. So we use the letter representation, not the actual number. All right. And here's another example showing you how to convert the hexadecimal back into its binary form. Okay. And here are some questions for you to try. I'm not doing any more working out for you. I gave you at least one working out for each, because the video is a bit long and I want to keep my videos as short as possible. Okay. Please leave your answers in the comment section. Here's another activity for you. Please leave your answers in the comment section, just in case you're not sure about something, and I'll make you a second video. Okay. Anyways, have a good binary day. Have a good binary day. I will make you another video on addition. I'm not moving on to another video in this. I want you to take in the hexadecimal, the denary, and the binary first. Tomorrow I'll post you a video on binary. All right. I have to go to work. So goodbye. See you guys. See you guys. See you guys. See you.